The nice thing about today's lesson is tomorrow we're doing the same thing. I do have more notes, but they should go relatively quickly, really quick. Not that notes ever take all that long. So on Monday, we learned how to two different methods for solving log equations. If you have a single log, then you want to isolate and give it a swirly if you have that single log situation. And then today, the other property we learned was the one-to-one property was also one we used. So we had two different methods on Monday. The single log swirly, isolate and give it a swirly. And then we had the one-to-one property where if you had a log equal to a log, that was easy to solve. Today, we might have to condense. And this is the entire reason we had properties of logs. If I have log base b of u minus log base b of v, what property allows us to subtract the logs? The division property, the quotient property, yeah. So I can take this whole thing and rewrite it using a single log, and then I just have to figure out what goes on top and what goes on bottom. So u goes on top, and the v goes on the bottom because it's got the negative. So today we are condensing first. All of these equations you have to condense right with one logarithm. What if we had log base b of u plus log base b of v? What property allowed us to add the logs? The product property, multiplication. So again, we write using a single log, and we get to multiply our arguments together, u times v. So again, today you're looking for when we have subtracting logs or adding logs. And if we have that, then we want to condense first. All right? And then it's just like what we did on Monday. So it's either the one-to-one property or the single log swirly. Okay? So we're sort of combining all of our properties. All right, let's see how this works. Example 1. Example 1, solve each equation and check. Really check. Example 1, solve each equation and check. Solve each equation and check. All right, we have log base 6 of 2. That is just a number, but I don't know that number. It's not one I can do in my head. 6 to what power gives me 2? Weird. I don't know. And then log base 6 of 3x squared equals 2. So here I have a log plus a log, and they have the same base. What property allows me to add the logs? The multiplication. So we need to condense this to a single log base 6, and we get to multiply then 2 times the 3x squared. We get to multiply those pieces together. The arguments get multiplied. So condense first is what we want to do today. And I'm going to clean this inside up a little bit. We've got log base 6. What is 2 times 3x squared? 6x squared. Very good. Is equal to 2. Now, this is the single log. There's only one of them. Single log swirly. Single log swirly. I love alliteration. It makes things memorable. Single log swirly. How do you drop a log? Give it a swirly. So we start with the base. We circle around and pick up our power. That's going to be 6 squared. And that's supposed to equal what? 6x's squared. Okay. So remember, logs don't just disappear. You've got to do something to get rid of them. All right. And in this case, it's the swirly. I'm going to, again, clean this up. 6 squared is 36 would be a better answer, yeah. All right, so how do we solve for x here? Eventually, what should we do first? Divide by 6, divide by 6. So we have x squared, 36 divided by 6 is 6. And then we can square root both sides. What do you need to remember when you take a square root? Plus or minus. So I have x equals plus or minus 6. Both of those answers happen to work. And the reason I know that is because if I were to think about checking that, I would plug the x value back in to the original here. Log base 6 of 2 plus log base 6 of 3 times, in place of my x, I'm going to go ahead and put my negative 6 and square it. And what happens when I take negative 6 and I square it? It turns positive. Negative 6 times negative 6 becomes positive 36. And so this whole thing ends up being positive. It'll work just fine. Remember, the problem is we don't want to see any negatives trapped inside of a log. All right? So this cleans up and it'll work just fine. Let's look over here. What is this funky thing? Ellen has bright blonde hair and gorgeous blue eyes. Natural log, very good. That is natural log. Natural log can be rewritten as log base e. And again, you do not have to do this. I happen to like doing this in Algebra 2 just so we can remember it. I do not do this in pre-cal. But you're learning here. This is the first time you've seen logs, so we want to be pretty careful. Log base e of x minus 5. Again, you can leave it natural log, but I just want you to remember that natural log really means log base e. Okay, so now that we know this is log base e, I have what property is allowing me to subtract the logs? The division property. So I'm going to condense this whole left side into a single log base e and write my division. What goes on top? Yeah, the 2x minus 4 is going on top. What goes on bottom? The x minus 5. Good. Top minus bottom. And that's supposed to equal log base e of 6. Now, is this the single log swirly or something different? This is different. This is the one-to-one property. What does the one-to-one property say? The one-to-one property says if the logs match, yeah, then they don't really matter anymore. We can sort of ignore them. If those are already equal to one another, then what must be true? Yeah, if the logs match, then the arguments should also match. And so we can essentially just look at setting those arguments equal to one another. I like this one. How do we deal with this weirdness here? What if I do 6 over 1? Then what do you want to do? Cross multiply. Very good. Yeah, so I don't want to divide by this thing, so we can actually multiply. Technically, we're multiplying both sides by x minus 5, but over here they just sort of cancel one another out. So that's how we can deal with that. Or just think cross multiply. We have 2x minus 4 is equal to, what do we have to do on the right-hand side then? Distribute. Yeah, 6x times, oh, sorry, minus 30, you're right. I said that. And now we can just get our letters together and our numbers together. I'm going to go ahead. What do you want to do? Subtract 2x? Okay. So we have negative 4 equals 6x minus 2x is 4x. And then we can add 30. 30 minus 4 is 26 equals 4x. And then we need to divide by 4. Divide by 4. So we get x equals 26 over 4, which reduces. You can divide by 2, 13 over 2. If you put it in your calculator, you could do that. You could say, hey, 26 over 4 is 6.5. You could then, 6.5 is a great answer as well. You can math frac that, and it is 13 halves. So use your calculator. Decimals are fine, but know that you have math frac as well. And I think most of the answers are going to be fractions on this worksheet. So fractions are just fine, ladies and gentlemen. When I take this number, I can plug it in, and natural log is a button on my calculator, so I can plug in the whole left-hand side to check. And I think I'm just going to use this 6.5 to check because it's easier to type in. So natural log of 2 times 6.5 minus 4. So that's my first part there. And then I'm going to subtract the natural log of 6.5 minus 5. Not times, minus 5. And so that whole left-hand side turns out to be 1.7917 blobbity blobbity. And I'm going to compare that to the right-hand side. Natural log of 6 is the same, 1.7917 blobbity blobbity. So do they balance? Yeah. And that's how you check. You check for balance. You check to make sure the left side and the right side are equal. Great, great, great way to check. All right, last one. Natural log of 5 minus 2x plus the natural log of 9 equals 4. This is another great one I can check using my calculator really easily. So again, I have this weird natural log. What is natural log? Log base E. I love how you said that. Log base E. And then 5 minus 2x plus log base E of 9 equals 4. So what do we need to do first? Multiply. What allows us to add the logs? The multiplication, the product property. So I'm going to condense it to a single log of what times what? Yes. 5 minus 2x times 9. The product property allows us to add those logs. So we're doing that in reverse. Add turns to multiply, subtract turns to divide. Okay, what do we have to do with this 5 times 2x, or sorry, 5 minus 2x times 9? Distribute, yes, you do need to distribute those together. So you have log base E of what? 45 minus 18x, bueno, okay. And then, now what situation is this? Is this a single log swirly or the one-to-one property? Single log swirly. Oh, the single ladies. Single log. You put your base up. Okay, sorry. All right. So we're going to start with our base. And this is why I wanted to rewrite natural log, so that you remember that the base is e. All right. So we would get e to the 4th power is equal to 45 minus 18x. E to the 4th power is totally crazy. It is a number. What is e? Not quite 3. It's totally weird, right? I'm going to go ahead and just leave it e to the 4th. That's a great answer. But I still need to isolate x. What should I do to isolate x? Subtract 45. So that's negative 18x equals e to the 4th, subtract 45. And then just divide by negative 18. Divide the whole side. And that's a great answer. X equals e to the 4th minus 45, all divided by negative 18. And that's an excellent answer. If you put it into your calculator and you wanted to approximate it, you have to do it in steps. Well, you don't have to, but that's the easiest way. E to the 4th minus 45, e to the 4th minus 45, I would do first, like that, and I get crazy decimal. And then divided by negative 18, and it approximates to be negative 0.5332, blah-bitty-blah-bitty. Okay? So it is important that you know how to type stuff like this into your calculator. You've got to do the subtraction first and then divide. Okay? Do you have questions for me? All right, cool. You guys have CP 43 today.